Hey, welcome back. Today we're going to talk about a very important Python package called Numpy. Even you are very new to Python, that's fine. You need to learn Numpy, which sounds quite complex because this is dealing with n-dimensional arrays, and also you're doing for computing. So it's very complex, sounds like do very scientific things, but trust me, if you are a beginner, this is really useful to you. So what is NumPy? We see the website numpy.org is website. Feel free to explore. There's a lot of information, a lot of examples. You can do it. Which in fact it is really simple concept is multi-dimensional array. And also it is another thing is how do you compute multi-dimensional array in a simple way. Actually, I believe even for computer science students, if you learn Python first, you learn NumPy first, which will give you different way to think. How do you write a program, especially how to write a parallel program in the future, which you can do very fantastic, sophisticated program to do high performance computing as well. Okay, let's do to create how to answer the first question. How do we create array? How do we access array? In the next 10 minutes, let's go over this. That's what you're gonna learn for this lecture. Okay, so let's say multi-dimensional array. So we can have one-dimensional, two-dimensional, three-dimensional, even 4, 5, 6. You can have very high-dimensional array. You can use it. However, most cases we use 1, 2, 3. Some cases we use 4. That's most cases we use. But let's go over these three most common used cases. So before you use NumPy, what you need to do is just import NumPy as NP. Get here. If we learned the first two lectures, we know that you can always use or import some package and give a very short name. Instead of have 5 letters, I have 2 letters. And same, we always want to visualize the array, visualize the data. So don't forget this matplotlib, which is your friend. Okay, which is imported as plot, P-I-T. Okay, so there are multiple ways to create arrays. The very first way to do is create from a list. So what is list? For example, we talked about last time. So let's a list is equal to, we have this, that is square bracket. We can put some numbers into it. Okay, so this is a list. This is not array in Python, although they look very similar. They have square bracket. They are a list of numbers. As you can see, a list it can be one-dimensional array, but if you convert this to NumPy array, you are actually getting much better functionality, much more functionality you can use. Okay, so what do we do? How do we convert that into array? So we can say A1 equal to, we use np.array. So that is what we have, just array, and then you put the list name here. So that is how you create from a list to an array. Okay, so let's try to print A1 so you can see that A1 is an array and a list is not. Okay, let's print a list. So a list is just a list, which is square bracket, but ny, when you convert to NumPy array, you see it shows like array, have this parentheses and has the list inside. Okay. So they are different, but you can exchange. Okay, so you can use array to do that, and also if you have another list, like say B list, see that equal to, and we can have a list of lists. For example, we can have a list of lists. So have 2, 3, 4. So what do we get? The B is a list of 2 lists, right? So this first list and second list. All right, so what do we do? So we can have a 2 equal to np.array array, and then we can have the put the b list into it. Sorry. Okay, so what do we have? So you can say, let's try to print a2. So a2 is array, but now we have it is two-dimensional array. So you can convert from a list of lists to a two-dimensional array. You can see this row, right? 2 rows, I have 3 columns. Okay, so this is one you can convert from list, but more interesting thing is we can also use Numpy provide a list of functions. You can use that to create Numpy array as well. So let's say a1 equal to np.zeros. There is something that provided by Numpy, and it gives you one parameter you can use, zeros. So the rest of them you can ignore them. You can just by default it's float. So what you do is a shape. Give it a shape. So what do you have? So if I say 10, what that means is I have one-dimensional array, and it has 10 elements inside, and it initialized as number 0, because this is zeros, means that let's create 10 zeros. This is a one-dimensional array. Okay, and also you can have, let's create another one called np.ones. So let's say we have 10 by 10. So what do we have here? This is a new array called a2, and this is not a one-dimensional array. It had 2 numbers, which means it's actually two-dimensional array. It had 10 rows and 10 columns. And what they are ones. So initialized, the array is initialized as ones. Every number inside this array is 1. Okay, you see 1 point, which means this is actually float. So it's a floating point. So it's a 1.0 actually. Okay, so that is you can use 0, you can use ones, you can use twos. No, there's no twos. Okay, so how about others? Let's see if you have additional one. How do we create? We can have another way to create a range. A range, for example, we have a 10. So what is a3 now? So let's still do a3. So we'll print it a3. A range is something like a list of continuous numbers starting from 0 all the way to less than 10. So you have 0 all the way to less than 10. Okay, so that is how you create this array. So we can have another way to do it is we can have a random. So we can have random. So you can have something like 10 by 10 as well. And then let's see what is a4. So a4 is a 10 by 10 random array. So they have all the random numbers into it. You can see actually it's 10 rows, but 10 columns as well. Okay, so you can do this as well. So when you have array, we can have attributes. So what attributes we have? So we can every array, let's say a1 dot, it has several attributes you can see. First one, it has it's shape. So what is a shape? Shape is it's one dimensional, two dimensional, it's 1 by 2, 2 by 1. This is a shape of this. So you can say another one is called dimensional, and A1 also have a size, and A1 also have a D type, which data type. So we can print them. We can say we can print 4 attributes. The first one is a shape. So A1 is one dimensional array. So it's size 10 by, actually 10 by nothing. So it's just 10. And it's dimensional, this n-dimensional, the number of dimensions we have, so which is 1 dimension. So you see it's 1. And the size, because it had 10 elements, so it's 10. And it's float 64 by default if you don't do anything. Okay, so let's try to do another one. Let's see what we have. The very last one we have is A4. Let's try to get A4. We replace them. Let's see what do we got. Okay, so A4 is not one-dimensional, it's a two-dimensional array. Its shape is 10 by 10, and its size is 10 by 10, which is 100 in total, and its type is still float. Okay, so that's attributes. When you have array in NumPy, you always have those 4 attributes. You can always use them. So we could plot them. I always like to plot something. That is very nice to plot things, you know. So we have the PIT. If you remember, we plot something, and it is very easy to plot in NumPy. You know, in Python, what you do is plot a plot. So what is A1? If we go back to A1, it's just 0. So that's why you see a straight line, because everything is just 0 at this time. So let's put something a little bit interesting. Let's look at A3. A3 is the range. So let's plot A3. You can see A3 is a straight line from 0 all the way to 9. So that is a straight line. It's all the number we have. We see that inside A3, you can plot them. Okay, so how about the other things? Let's look about this A4. How do we plot A4? We can see a little bit of A4. So A4, because A4 is a two-dimensional array. So if we do this, like pit.plot, like A4, what we get is a list of, you know, the sequences. It doesn't treat this as a 2D array, but it treats it as a list of lists. You can see that it has 8, because this is A4 is 10 by 10. So basically, A4 is 10 by 10. So it has 10 lines. It tries to show 10 one-dimensional arrays. You try to display like that. It's, if you really want your data look like that, sure, that's fine. But generally, if you have a two-dimensional array, you want to display that as a spatial information. So it look like a picture, or look like some kind of spatial correlation you want to show them. So what we do is, here is another one called image show. Let's look at, play this like an image. So let's do this, A4, so we can try to see that. All right, so this looks more interesting to me, is that this one, instead of showing a linear correlation between one-dimensional data, here I show it's not just its own, but also around its neighbors. You see everything that's, for example, this is A4, 0, 0, and that is the very first element, this is the last element. Everyone can see the neighbors. Okay, I can also we can plot the color bar. Okay, so if we type this plot the color bar, you can see this is the color bar shows the value. Everything we show the value, and then we use the color to represent the value, because we want to visualize the data. So what you see is, for example, this A400. Let's go back to here. What is the random number we got at the very beginning? So that is a very small number, 0.01. So you see it used a very dark color represented, because look at this. It's 0.01 is in the color bar, is somewhere here. So that is dark blue color. So you see this dark blue color. And it's go pretty close to 1. You see these numbers kind of showing this light yellow color. So that looks, you know, try to show the difference there. Okay, even more, we can display even 3D. You see, this is an example that I can use random. I just create not just two-dimensional array. Here we have 3 numbers, 8 by 8 by 8. So what do we have is we can create 3D three-dimensional array. So you can run this one. You can see that this A3 it's become a lot of numbers, because 8 by 8 by 8. Okay, so and how do we display them? We can display using this method. So here you can use this still the plot has axis, but now you try to projection equal to 3D, and then here you try to get the coordinates of each point each number in the 3D array, and then you can display them using two methods. One is this, first you show the color, show the coordinates, and then show the color, use the z value, and then you show the size. We want the value equal to show the size. So the size represents the value of these numbers. And we type 100 because it's kind of 0.001, it's very small. We type 100, so you can see this is a nice visualization to see this three-dimensional data. Okay, so I think this is what we can talk for this lecture, and hopefully you get what you can do. Use a NumPy array, and then it's how do you create an array. We will talk about next time. We'll talk about how to access it and how to compute it. Hope you enjoy this video. We'll see you next time.